Hello, thank you so much for choosing to come and spend your afternoon here at the museum. My name's John. Do we have any scientists in the audience? Woo. We do! Ah! Of course, I'm a scientist as well. It's a trick question, of course, because in actual fact, every single last person in this room is actually a scientist. Since I was up at the Fringe last, a couple of years ago, I now have a daughter. She is 8 months old. And guess what? She's a scientist. At the age of about 3 or 4 months, she started asking questions about how the world works, formulating hypotheses about the world, and performing experiments to test her hypotheses. And that's what makes her a scientist. She doesn't yet have any language to put these questions into, but she's still asking the questions, yes? She's figuring out some anatomy. Is this my hand? Causality. What happens if I do this? Or this? And the passage of time. Day follows night, follows day, follows night. Which one is for sleeping? Maybe neither of them. She's still figuring things out. But she's getting there, okay? And that's what makes her a scientist. And as long as you keep asking questions about how the world works, you'll be a scientist as well. So, what I thought would be a good idea is to write a song about science for every letter of the alphabet and to perform them for you today in order, starting with A, ending with Z. What I also thought I would do is to write each of these songs either in a style of music or on an instrument starting with the same letter of the alphabet. I thought it would be a good idea. This is where the game comes in. You've got in your hands a sheet of paper which is a program on one side, a game on the other side. And you should also have a pen or a pencil in your hand. If you notice that I am attempting a genre of music or attempting an instrument that starts with the letter of the alphabet we're currently on, make a note of it. It says there that you won't win a prize, but I have prizes. Yeah? The top score so far is 39 out of 26. All right? So I'm going to give you all 1 point to start us off with, so we're all off the starting block together. I'm going to perform the first song a cappella. Can someone tell me what that means, please? Okay, this is my Ensonglopedia. I'm going to magically open the first page like this. Here are some of the words in science starting with an A. I'm going to sing a song about one of those, and I'm going to perform it without any instruments, just using my voice. And I'm going to give myself a note, so I know what note to start on. I'm going to start on that note there. Can anyone guess what note that is? It's an A. You must have a perfect pitch, yes, or just understand the concept of the show. Probably that one. Okay, are we all ready? Are we all excited? Yeah. Is everybody at least 20% as excited as I am? Yeah! Yeah! Oh, wonderful, I'm so glad. Okay, let's do this thing. Here we go. Let's do a Fringe show or something. Atom. From the Greek words a, meaning not, and temne, to cut, because it was thought that atoms were unbreakable and utterly unshakable. No part of them was takeable, their oneness unmistakable. But now we know they're breakable, and we do it quite a lot. An astronaut has trillions of atoms, and that's just in a single strand of armpit hair. So hold on to your noses and let us see what happens if we take a trip in there. A-T-O-M, impossible to count cause there's so many of them. A-T-O-M-I-C, so small that they are totally impossible to see. So let's dive down to the depths of the atom. It's a world so wild that it's difficult to fathom. The tiny things whizzing round the outside are electrons 5 or 6 femtometers wide. A simple fact that you've got to embrace is that most of an atom is empty space. If an atom was as big as Westminster Cathedral, the nucleus would be a baby bee busy buzzing in the middle.
A-T-O-M, impossible to count cause there's so many of them. A-T-O-M-I-C, so small that they are totally impossible to see. Now back to the B. That B is made of hadrons, which are protons, or neutrons, which are held together with the help of gluons. Now we're getting quite advanced for the brightest sparks, but hadrons actually consist of quarks. And of what sort of things do those quarks comprise? Well, if you can tell us that, you win the Nobel Prize. A-T-O-M, even air is literally swarming with them. A-T-O-M-G, I can't believe that there are also many, many trillions of those things in me.
Big bang, little bang, somewhere in the middle bang. Big bang, little bang, somewhere in the middle bang. Big bang, little bang, I'm gonna look at
3 bangs of different sizes, and then I'm gonna look at why each one arises. Bang 1 was one hell of a bang. It was the biggest ever bang that was caused by man. It was the detonation in 1961 of the 57 megaton Tsar bomb. Dang, what a bang! Bones shook, ears rang. The island of Severney was a bad place to hang on October 30th when that thermonuclear warhead blew. Man, it was big, but not as big as Bang 2. Bang 2 was back in 2013 and was the biggest bang of any sort that man had ever seen. It was a gamma ray burst, the explosion of a star 3.7 billion light years away. Well far! Dang, what a bang! Of such colossal size that a similar one much closer would lead to our demise. It was spotted by the Fermi Space Observatory. Man, it was big, but not as big as Bang 3. Bang 3 was a mother of a bang. It was the bang in which time and space themselves began. A little under 14 billion years BC, the bang occurred that kick-started reality. Dang, what a bang, and what's more, it's still going, and the radiation from its early stages is still glowing, though it started out infinitesimally small. Man, it was big, it was the biggest bang of all. Big bang, little bang, somewhere in the middle bang. Big bang, little bang, and so I've looked at 3 bangs of different sizes, and now I'm gonna look at why each one arises. Bang 1, the Tsar bomb, was a test run for an even bigger bomb developed in the Cold War. Luckily, the war ended before it was deployed and before a major city could be destroyed. Bang 2, the gamma ray burst occurred when lots of high-energy photons were dispersed from the site of a gigantic supernova, which meant that the life of a very big star was over. Bang 3, the Big Bang, how did that one come about? Well, the fact is we just don't know, and I doubt that there'll ever be an answer to which we all agree. That's A and B dealt with, now on we go with C.
cell. From the Latin word cella, meaning, well, cellar. You know, like the room in your house where you store all your wine. And no matter whether you're a girl or a fella, your cells look a lot like mine. Okay, there's a little dance you can join in with this one, okay? You can do it from your seats. Here we go. You got to swing
those cells in your hips so that you can join me in the cell calypso. You got to move every cell in your feet. I want to see your cells a-jiggling from across the street. So when I see you shaking your body, it's like your cells are having some kind of party. Every cell is designed for a particular task. Your muscle cell do what your brain cell asks. Oh yes! Your body's always redesigning in lots of ways. You'll get a new stomach lining in just 4 days, and a new set of lungs every 6-ish weeks. Every month you'll get a brand new layer of skin on your cheeks. Your cells duplicate when they get worn. You are not the same person as when you were born. Oh no. Ought to know that deep inside of your cells are little blobby things they call organelles. These organelles, they do all the hard labor that gives all the cells their distinctive behavior. They make proteins and help the cells duplicate. replicate. If you didn't have cells, you'd be in a right state, oh no.
Can you please stand up and turn and face this way? And then place your hands on the shoulders of the person in front. Anyone else who wants to join in, you're very welcome. Here we go.
And now it's time to do the Ensonglopedia conga. Na 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 na, hey, na 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 na, hey. I promise you that nothing can possibly go wronger. Na 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 na, hey, na 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 na, hey. It shows you how the cells work together to be stronger. Na 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 na, hey, na 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 na, hey. But now we've reached the end of this most peculiar songa. Na 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 na, hey, na 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 na, hey. Which means that we can't do the conga any longer. I'm gonna delve deeper into the human cell through the nuclear membrane, the protective shell in which 46 molecules have set up home. They're made of DNA and they're the chromosomes. They're made of DNA, deoxyribonucleic acid. DNA is the set of instructions that gives the directions for how the cell functions. It's the code so the organism knows how to grow. Where the feathers feature, whether you're adapted for the snow. It was DNA placed those ace features on your face. Drop, 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 the nucleobase. When a cell divides, it first makes a copy of the DNA, but cell division can be sloppy and new DNA may have tiny mistakes. And know what affects a mistake sometimes makes mistakes can cause diseases like cancer, but changes also mean there's a chance of mutations creating health and adaptation. That's evolution, but it takes a lot of patience. Generations upon generations, and it's all thanks to DNA, deoxyribonucleic acid. And now that we know how the code fits together, we can set to work and make unhealthy organisms better. DNA is the key to the needs of the species. Diseases can cease if we replace the right pieces. Splice that code, cut it up, rip it, flip it, drop it in a new place. With my programmable endonuclease, but only under supervision of a highly regulated lab space. Drop the nucleobase. Adenine, guanine, thymine, cytosine. These are the bases, these are the jigsaw pieces that make up each gene, which fit together to help my body parts slot neatly into place. This double helix rises like a phoenix to continue the race. Drop the nucleobase.